So we're now going to solve this system of three equations in three variables using the row reduced echelon form of a matrix. So first we need to build the augmented matrix. We have three equations, so our matrix will have three rows. Each row will represent one of the equations, and then we will have a column matrix for the constants. So let's see, like this. We have an equation 1, 2, and 3. So equation 1 will be in the first row, 2 in the second, and 3 in the third row. And now each column will represent one variable, and then we'll have the constant column at the end. So let's see. So now let's go ahead and build a matrix. So we have in the first equation that's going to go in the first row, we have 1x1, negative 1x2, negative 1x3, and 3 is the constant. In the second equation, we have 1x1, 1x2, 2x3, and 1 is the constant. And in the third equation, we have 4x1, negative 2x2, 4x3, and 1 is your constant. So now we're going to put this in the calculator, and we're going to ask the calculator to calculate the reduced row echelon form. The following calculation will be given to us. The first row will be 1, 0, 0, 1 half. The second row will be 0, 1, 0, negative 3 halves. And the third row is 0, 0, 1, negative 1. So what we see here is that this is actually an equation with three variables that has a unique solution. So here, if I pull out, the first row will tell me 1x1, no x2, no x3 equals 1 half. So x1 equals 1 half. No x1, 1x2, no x3 equals negative 3 halves. So x2 equals negative 3 halves. And then finally, no x1, no x2, 1x3. So x3 equals negative 1. So here is our solution. And in this case, this is a pretty special case when we have three equations in three unknowns and we had unique solution. All right, now let's go ahead and look at a different system. This system looks very much like the first system. We again have three equations and three unknowns, so we could have another unique solution, but we might also get something different. So let's go ahead again and build the augmented matrix just like before. So again, the first row will be first equation, negative 2x1, negative 6x2. Notice there is no x3, so that's 0x3. Minus 10 is the constant. Then we have 1x1, 3x2, 3x3, 12 is your constant. 4x1, 12x2. Again, we have no x3, and 20 is the constant. So here's the augmented matrix. And again, we're going to plug that in the calculator, and the calculator will give us the following reduced row echelon form. We get 1, 3, 0, 5, 0, 0, 1, 7, and 0, 0, 0, 0. All right, so here, this is not a unique solution. The reduced row echelon form was actually put this into two equations with three unknowns. So what we need to look for is how would we write the solution. So we first identify the columns that have a pivot. So if we go from left to right in each row, we're going to see which row has A1 as a first entry. So first non-zero entry. So right here, this is the leftmost one or the leading one, or sometimes we call it pivot. In the second row, we have 0, 0, and then the first number is 1. So column 1, that stands for x1, and column 3 are the pivot columns. So we're going to solve for those. Notice column 2 does not have a pivot, so that's our free variable. So this one is free, and that's going to be our parameter, our choice, right? Since it's free, we can choose whatever you want for that variable. So now let's go ahead and see how would we write the solution. So your solution should always be written as a list of all of your variables. Here, x2 is your free variable, so we're going to call it t. It can be any real number, right? So we can choose. So now what about x1? So if I look at x1, let's pull out x1 equation from the first row. We get 1x1 plus 3x2, 0x3 equals 5. If we solve this for x1, what do we get? We get x1 equals negative 3x2 plus 5. But what do we know about this x2? This x2 is the same as t. So we would write that x1 equals negative 3 times t, whatever you choose for x2, plus 5. Alright, and now finally, what is x3? So the second row tells us what is x3. 0x1 plus 0x2, 1x3 equals 7. So x3 is always 7. So notice, x3 is always 7, x2 is whatever number you choose, but this choice of x2 determines what your x1 is going to be. So for example, what would be possible solutions? In this case, we can have infinitely many solutions. They just simply depend on my choice of x2. So I can have this solution. x3 is going to be always 7. What if I decide that x2 is a 0? So t is 0, so now I'm going to plug in to solve for x1. Negative 3 times 0 plus 5 will give me 5. So x1 is 5, x2 is 0, and x3 is 7 is one possible solution. Can I have another one? Sure. Let's choose x3 to be, well, x3 is always 7, so I can't choose x3, but let's choose x2 to be 1. Can do that. What would be x1? Negative 3 times 1 plus 5, 2. So 2, 1, and 7 is another solution, and I can figure out as many of them as I want. Here, if I write it all together, this is all of the solutions listed together. So these are all of the infinitely many solutions, and we call this the parametric solution because the solution depends on the choice of the parameter of the t that we choose. Parametric solution, or solution. All right, let's look at one more example that looks different from the very beginning. So in this example, we have 2 equations and 3 variables. So this tells me right away that I cannot have a unique solution. For a unique solution, I would have to have at least as many variables as equations. In this case, I have more variables than equations, so I will definitely get a parametric solution if the system has a solution. So let's go ahead and figure out what the solution would be to the system. So again, we're building an augmented matrix, and here we have 2 equations, so we need 2 rows. Each row will represent one equation, and then the columns represent the variables and the constants. So again, we have 2x1, 3x2, 4x3, constant is 2. And then in the second equation, we have 1x1, 3x2, 5x3, and the constant is 11. Now let's go ahead and plug this in the calculator and calculate the row reduced echelon form. And we get 1, 0, negative 1, and negative 9. And then we get 0, 1, 2, and 20 over 3. All right, so let's see what we got here. So again, we first of all we'll go and identify the pivots, right? So the first row, the first non-zero number that I hit is 1, so that's a pivot. In the second row, I hit 0, and then the first non-zero number that we find is again 1, so that's a pivot as well. So in this case, x1, the first column has a pivot, and the second column has a pivot. So these are the ones that we're going to be solving for. So we're going to solve for x1 and x2. Notice x3, this column right here, does not have a pivot in it, right? So that doesn't have that leading one, the first non-zero one in each row. So that doesn't have a pivot, so it is free. So that variable is free, and we're going to call it the parameter, right? So we can choose anything we want for x3. So this is my parameter is x3. So I can already start writing. When I write the solution, I can already go here and say x1, x2, x3, right? So you want to solve for every variable. In this case, t is the x3 is the parameter, is my choice. I can choose whatever I want t to be. All right, now let's go ahead and write what the other two equations would be from each row. So if I take row 1, I'm going to write it right here. Row 1 gives me 1x1, no x2, minus x3 equals -9. So again, solving for x1, we have this pivot here, so we want to solve for x1. x1 equals x3 minus 9. So this is what x1 equals. Notice x1 depends on x3, so it depends on your choice of x3, because we can choose whatever x3 is, and x3 we decided to just call that t. So this is just t, right? So now we can write x1 in this form. x1 will be t, whatever you choose for x3, minus 9. And again, t is any real number. I can choose anything I want, but the moment I choose this x3, it will determine what x1 will be. It will be my choice of t minus 9. All right, now let's go ahead and look at the second row. So let's pull out the equation from the second row. So here we get 0x1, 1x2 plus 2x3 equals 20/3. And so now solving for x2 again, we have this this pivot in row 2, so we want to solve for x2, will be minus 2x3 plus 20/3. And again, the x3 right here is your choice, right? That's the parameter. So this we call t. So now let's go ahead and write it down. So x2 is negative 2t plus 20/3. Right, so let's go ahead and choose, let's go ahead and figure out what would be possible solutions, right? So possible solutions, let's hear, possible solutions. So if I choose t to be 0, that's kind of a nice, easy number to calculate with. So if t is 0, x1 will be 0 minus 9, negative 9. And if t is 0, x2 will be negative 2 times 0, which is 0, plus 20/3, 20/3. So negative 9, 20/3, and 0 is one possible solution. What about another possible solution? Let's choose t to be 3. So what would be x1? It will be 3 minus 9, which is minus 6. What about x2? X2 in this case will be negative 2 times 3 is negative 6 plus 20/3. So that would be what? If I make negative 6 into thirds, I'm going to get negative 18 over 3 plus 20/3, which will be 2/3. So negative 6, 2/3, and 3 is yet another possible solution. We can come up with infinitely many solutions depending on the choice of the third variable, x3. And we can choose any real number. They don't have to be pretty numbers like we chose here. We can choose x3 to be negative 7.43 and still calculate x1 and x2. But the important thing to notice is that your choice of x3 will determine both the value of x1 and x2. So here we have another parametric solution. And if I want to write all of the solutions at the same time, this would be the way to write them. This is another parametric solution.